We draw up a probability distribution table when we can work out all the probabilities for one specific variable, and then we place all of those different outcomes in one specific table. So the first thing you're going to do is you draw a table with your nice, neat ruler lines. Okay, and if we use the example, the roll of a dice. Okay, so if I'm saying the roll of one die is going to be my variable, which is then x. Okay, for all the outcomes of that, we can then write it down. So we can say each individual outcome is the small letter x, and when we roll a dice, it means we can either get a 1, a 2, a 3, a 4, a 5, or a 6. And then underneath that, we write the probability of getting that outcome. So we say P for probability, where our capital X for our variable equals our small x. So that means that when our roll of the dice equals the 1 or 2 or 3 or 4, etc. So the probability of getting a 1 when you roll a dice, you know, is going to be 1 over 6, because there's only one side that has a 1 on it out of the 6 sides of the dice. Same for 2, it's 1 over 6, 1 over 6, 1 over 6, 1 over 6, and 1 over 6. So the probability remains the same for each of those because the probability of getting each side remains the same. But then that is then what our probability distribution table looks like. So if we look at a different example where the numbers are going to be different, here we have George that needs to replace 2 used batteries in his torch with new ones. But when he takes them out, he mixes up the old batteries with 3 new ones in his hands, and all 5 batteries are the same in appearance. Now he selects 2 batteries at random from the 5 batteries that he has, and we need to draw up a probability distribution table for X being the number of batteries selected. So our number of batteries selected is going to be X, as we're told. So that's the number of batteries. And he's choosing 2 in total. But out of those 2, he may have selected no new ones, or he could have selected 1 new one, or he could have selected 2 new ones, because we want the number of new batteries, and we don't know what those are yet. So we need to work out the probability for when he has 0 new ones, 1 new one, and 2 new ones. So the easiest thing to do is first draw a tree diagram, so we can easily place all of our probabilities. So we can say that N is for new batteries and U is for used batteries. Okay, and if we're going to draw up our tree diagram, on his first pick, when he picks the first battery, he either picked a new one or he picked a used one. The probability of him picking a new one first, there was 3 new batteries out of the total of 5 batteries. So that's going to be 3 over 5. And there was 2 used batteries in the 5 batteries, so that's going to be 2 over 5. Then his second pick, out of the remaining 4 batteries that he's got, he's going to pick again. And he's either going to pick a new one or a used one, or new one and used one. So if he picked a new one the second time, now there's only 4 remaining batteries. If he had picked the new one first, that means he only had 2 new ones left out of the 4. And he still had 2 used ones left out of the 4. If he picked a used one first, that means he had 3 new ones left out of the 4. And he only had 1 used one left out of the remaining 4. So there we have our tree diagram. And from that, we can then work out the probability for when X means no new batteries, the probability for when he has one new battery, and the probability for when he has 2 new batteries. So the first one, if he has no new batteries, that means he picked a used one and a used one. So remember, and means multiply. So we're going to say a used battery times a used battery, which is then 2/5 times 1/4. And if you type that in your calculator, you get a final answer of 0.1. If he's going to pick one new battery, he's either going to pick a new one first and then a used one, or he's going to pick a used one first and then a new one. So we've got to have both. So he either says new and then used, so multiply, or, so we're going to add used first and then new. So if we fill in our probabilities, a new one first was 3/5 times the used one was 2/4 plus the used one 2/5 times the new one 3/4. And if you type that in your calculator, you get a final answer of 0.6. And then our last one, he chooses 2 new batteries in a row, which means he picked a new one and a new one. So there you're going to have n times n, which is going to be 3/5 times 2/4, which gives me an answer of 0.3. So now we have the probabilities for when he picks 0 batteries, 1 battery, 2 battery. So final step is we need to draw up the probability distribution table. So with our ruler, we draw in the lines. We say small x for each value that he chose, and then we say the probability that our variable equals that x. So the x is then 0 or 1 or 2. So for 0, the probability was 0.1. For 1, the probability was 0.6. And for 2, the probability was 0.3. And there is our final answer, because that's our final probability distribution table. And in a different example, instead of using values now, they've used letters and we have to find values. So in this one, in a probability distribution table, we have a random variable x that takes the value small x with a probability of kx. So what that means is for every value of our variable, the probability is k times that number of that variable. And we were then told where x takes the values of 5, 10, 15, 20, and 25. And we need to draw up the probability distribution table and find the value of k. So in our table, we always have our small values of x, and we have the probability that our variable equals that. And we are told that those x values are 5, 10, 15, 20, and 25. So now the probability is going to be k times that x value, which means the probability here is k, and then the small x was 5. So that. And another way of saying that is just 5k. The same then applies for 10, 15, 20, and 25. Okay, now all the probabilities in this table always add up to 1, because you know that all the outcomes for a specific probability always add to 1. So because we know that information, we can find the value of k by saying all of these summed together equals 1. So we can say the sum of the probability for our x variable equaling a small value of x equals 1. So the sum is then our 5k plus 10k plus 15k plus 20k plus 25k all equals 1. And when you add up 5 plus 10 plus 15 plus 20 plus 25, you end up with 75k equal to 1. So that means 1k is going to be 1 over 75. So there is our value for k. And then if they further ask you to do anything, what you can do then is you take this value of k and you sub it back in to get the final values for each in the table.